welcome to the dOrg hot seat. First of all, thank you for coming over. So dOrg is a builder DAO. We are a builder guild organized as a DAO, one of the first DAOs to ever be associated under an LLC framework. I think that was back in 2019. Thank you, Clara. And yeah, since then we've been trying to sort of like engage the members to keep learning on the different protocols that are coming, on the to keep updated on the new languages, the new protocols, the new innovations that there are. And we started doing this sort of like internal calls where we invited people from outside to explain. It was not a lot of like rapid fire kind of like, okay, why should I be using this? I'm a developer. What is the protocol? What do I use it for? How can I start integrating it right now?
Everybody, let's get into it.
Let's get started. Okay, so one of the first things that kind of shocked me when I learned about lead protocol is this idea of keeping secrets in a decentralized way and being able to retrieve them also in like a permissionless manner, right? How does that work? Can you tell us a little bit more about lead protocol?
Yeah. Absolutely. Oh, you're totally right. This is like the aim here is quite ambitious, and there's a big desert of teams that have attempted to do what we have successfully done, which is manage secrets in a decentralized way. This is a generational problem in computer science. Anybody who's been around any kind of software development has probably asked themselves the question, well, where do we store the secrets for this application? And so the insight with Lit as it relates to the design and the architecture is to use two technologies, and I'll describe them in just a moment, and stack them in a method that is known as defense in depth. And we can talk a little bit about defense in depth too. But those two core technologies, the first is called multi-party computation threshold secret sharing, sometimes referred to as MPC TSS. This is a method to store a secret across a distributed set of parties in a threshold that is often articulated as T of N, where you need T of the what's called a key share, or a part of the key of the total set N, in order to produce any operation with that key. And so the core two operations with a key, things like signing, or well, they are signing and encryption. On one hand, we have what we'll call threshold MPC or MPC TSS. Threshold MPC has one core issue, one core security issue, which is the ability for the parties that are holding the key shares, the parts of the secret, to collude with each other to steal the secret, which is obviously not good. And that is where the second piece of technology comes in, which is something called encrypted virtualization. This is a category within the broader category of secure hardware, also called TEE, trusted execution environments. And so functionally, what Lit protocol is a threshold MPC method that runs inside a network of TEEs. And then the one other thing to note is that in this network, comprised of TEEs, each with a key share set up in the T of N format across them, there's also a JavaScript execution environment that runs inside of each of those TEEs. The developers can articulate any arbitrary logic that governs how the distributed key will sign things and encrypt things. And so we can get into all of the use cases for this, but that's the general construction of the primitive.
I don't think I could have explained it better. That was amazing. That was a really concise, really specific information about what technologies are we leveraging here in order to have this sort of like sangria of decentralized secrets. But There's always a but. TEEs are not safe.
Right. And so this is the
TEEs have been
whole.
broken. TEEs have been broken so many times. The trusted execution environment paradigm, SGX has been just broken and it keeps broken and they keep patching it, it keeps getting broken. As long as the hardware is in an unsafe, untrusted location, it will be vulnerable to hacking. So what are you doing to tackle this problem?
Yeah, this is the insight of the design of the defense in depth. So the system doesn't fully depend on the threshold cryptography because of the TEE, but it also doesn't fully depend on the TEE because of the threshold cryptography. There's a relationship of reciprocity between these two technologies in this defense in depth method. So let's take the worst case scenario, right? The worst case scenario is that the TEE fails. What still needs to happen at that point is the node operators would still need to collude with each other. The threshold would need to be broken. And so one of the, like, oftentimes when you hear, this TEE has been broken, it's often vulnerabilities from a physical attack perspective. And so the
Yes.
node operators of the lit protocol are all running in allow listed data centers. And in the set of normal operations, they also do something called a key refresh every half hour. So in order to break lit, what you would have to do is within a half hour time period, have a globally coordinated break and enter scheme where you perform a physical hardware attack across a threshold of the nodes into armed data centers across a bunch of different parties that decide to collude.
Nice.
Yeah,
Perfect. Perfectly explained. Thank you. Okay. So now we have a way to distribute and encrypt all these secrets. What can we use them from? Actually, that can be like we can be quite creative on that regard, right?
totally. Yeah, that's the light bulb moment is kind of recognizing this as a new primitive in the same way that Ethereum introduced a mutable but updatable state. Lit introduces a mutable but updatable signing and encryption. And the three use case categories that are most popular are using this distributed key for private data, like in the context of a data marketplace. Example there is Fox Corp has a blockchain product called Verify for letting media organizations syndicate or buy and sell rights to media. And the way that it works is every article is encrypted to the lit key and stored on IPFS. And then if somebody wants to access that media article, they buy a license on chain. And then they say to the buyer says to the lit nodes, hey, I've got the license. The lit nodes it's a one-to-many operation from the buyer to the lit nodes. The lit nodes then all independently check, does this buyer have this NFT? And then, oops, make my camera blinked off. And then send the decryption rights back down to that buyer. So private data is one case. The next case to talk about is chain abstraction. So products like Genius Terminal, they just launched recently. You should definitely check them out. They enable cross-chain swaps across any blockchain in seconds rather than minutes. And the way that they're able to do that is quite cleverly, they're using the decentralized programmable key to manage a bunch of liquidity across blockchains. Let's just take like Base and Solana, for example. If I want to go from USDC on Base to AI16Z on Solana, the flow inside of the Genius app, who's implemented this, is that my funds go to a wallet on Base that is the liquidity orchestration wallet, which is also is a lit key in this case. And then in parallel, the liquidity orchestration on Solana buys the meme coin and sends it back to the user's wallet. And that all happens in parallel. And therefore, no waiting the 15 to 30 minutes to bridge from Base to Solana is required because the keys themselves maintain the logic around that orchestration, private data, chain abstraction. There's also a bunch of exploration around chain signatures where somebody can call a smart contract function on a blockchain that creates a threshold MPC key that then creates and broadcasts a transaction to a destination chain. So there are some chains that have this implemented already. I think there's more coming. We're starting to see chain signatures being thought of as almost a commodity that every L2 and every chain should have. And then the third category, and I think this may be interesting to a lot of folks here, and where we've been putting a lot of effort and are seeing an enormous amount of integrations, is answering a pretty core problem as it relates to the emergence of the agentic web and the use of AI agents. And so, just for a little bit of context setting, where we are broadly right now is what some people have described as wave one of AI applications, where an AI application delivers information to the user, like ChatGPT or character AI bot on Twitter. It's sending information somewhere. Where we're starting to move into is what folks are calling phase two, which is where agents do things on behalf of users. And so, if you want to have an agent trade cryptocurrency on behalf of users, a very important question arises, which is where do you store the agent's private key? That is, signing transactions without the human in the loop. So an example of this would be a user says to an agent, please do yield optimization for me across all of the blockchain networks. And they say go, and then they disappear. For most of the agent kits that exist today, they're quite simple in the key management regard. They implicitly trust the developer of that LLM, of that agent, to manage the user's private key as a config variable. Now, this is not a sustainable or long-term way if we were going to actually move into an agentic web where hundreds of millions and billions of dollars are transacted with agents. Trusting every individual agent developer in that case doesn't quite work. And so the lit agent wallet, using this underlying power of the programmable distributed key, is a method to let and I can actually, this is going to come through, I can actually show a helpful image here, is a method when an LLM says something like buy one Ethereum, um, that order is passed to the lit agent wallet. The agent wallet will then check against a set of policies that are managed on chain. The unpictured party here is the agent owner, which can be an individual, a DAO, a smart account on any chain. And that party, the agent owner, the agent admin, can update the policies, things like what's the spending limit, what are the allow lists of contracts that can be used, etc. And so the compute in lit checks against this set of policies. And then if it passes that policy check, the transaction is crafted inside this key management network and broadcast to chain. And this, I would say, one of the most exciting frontiers as it relates to AI agent applications. It really starts to, I think, lay the groundwork for this next version of the internet that we're moving into, where apps kind of disappear. There's one app, the app where you say, hey, agent, please do something for me. And then in all cases, when you have an AI operating on behalf of a user, the user's authority is always represented as some secret. In blockchains, it's a private key. On web apps, it's an API key or password. In e-commerce, it's a credit card number. And so this agent wallet method, it's initially focused on cryptocurrency transactions, but it's actually applicable to all kinds of transactions in terms of managing the user's secret without exposing that to the developer or to the LLM. And also letting that user have guardrails, tools, policies, capabilities that they manage themselves on chain.
How is that different from a account abstraction, for example, where you or how does, maybe it's not different, maybe it is complementary to both account abstraction and intent. Like by generating these intents and these intent networks, how does it fit into this scenario?
Yeah, so let's take those piece by piece. On the intent network, an intent network happens after an order has been created. In the agent web, we're actually taking a step back. So let's say you order your agent and you say, you know, buy me $20 of Ethereum every other day. At the time that the LLM is then processes that and goes, I processed one transaction 2 days ago, 48 hours has elapsed, time to process another transaction. That transaction can then be the input into an intent network to then solve that specific transaction intent. But there's another layer of orchestration beyond that in terms of the automation and the LLM deciding like it's time to process another transaction. So, and the big leap there is that the human is out of the loop. And yeah, this is deeply complementary with account abstraction. Those policies are like not in all cases, but can be drafted as modules and details on an AA or account abstraction or smart account wallet. Um, and in that case, you still need the signer. You still need some initiator, right? Like essentially, an interesting way to think about account abstraction or a multi-sig is it is your authority management system, but you still have off-chain signers, whether those are pass keys, an automation system like Lit with guardrails, um, private key, or whatever other authorization scheme that you've hooked up into the smart account.
Right. So you'd give a smart account permission to use that module, which with its own set of keys that are allowed to do certain things, to be able to sign for you and initiate those transactions as well as the module.
And you could
Yeah.
scope those with the policies in the smart account, where you say, oh, I have
Right.
a. Please go ahead.
I'm sorry. Go ahead.
Yeah, you could say like I'm the main signer as the individual with my MetaMask key on the smart account, and also I'm going to give permission to this other signer for my automation. Then I can have constraints around what can be signed there, articulated in the smart account.
Yeah. So I want to go into like how would an integration with Lit protocol would work. But before, since we're on the topic, let's just touch very briefly on these policies that you're mentioning. Is that something that the you provide templates for or a framework for, or is that something that each developer has to create on their own?
Yeah, there's a growing list of them. So far, they're all open source. There's a handful on Ethereum and Solana, largely focused on some of the core stuff, swaps right now. But it's an open source ecosystem. We're starting to see people build these tools and policies for things like OTC deals, NFT marketplaces, setting up vesting contracts. Because what's interesting about these policies is they can be very, very broadly scoped, right? Like, sign anything as long as it's Tuesday would be a very broad scope, or they could be highly scoped and granular and specific, which is to say, this agent can use this contract, and within this given contract, there's a specific variable that, like, let's say it's a swap. Let's say it's Uniswap, for example. On Uniswap, you can only trade this set of allow list tokens, and then there's a spending limit for that. It really depends on what wants to be implemented. There are templates to get started with, but just like everything related to the question that you just asked, it depends on the use case.
Right on. Would a helpful framework to understand what those policies are be similar to the strategies on Snapchat, for example, where you have like this list where you can create your own or just pick and choose from existing strategies and just plug in your token, and you'll be using someone has already developed that strategy for that token, etc. And you just for a generic ERC20, and you just plug in the value. Yeah. Okay. Gotcha. So how would I go about using Lit protocol in my application?
Yeah, so there's an open source JavaScript SDK. The docs are developer.litprotocol.com. The underlying network is quite an extensive machine. It's essentially a key management system with Lambda functions. So having some idea around what are you trying to accomplish with this computer definitely helps advance the direction. But we have a bunch of like ideas and a bunch of suggestions around how to get started. There's a growing list of fully forkable guides and implementations for a bunch of use cases as well. Um, but yeah, I would say, just like with building every product, starting with what's the ideal user flow. I want the user to do X, Y, A, B, C, and get these given benefits out of that. And then if you need a method for programming signing or encryption in that flow, there's likely an example. If there's not an example for your specific idea already, all of the primitives are there, and we can help you figure out any details if you get stuck.
Hey guys,
Hey,
Lansky, you're muted by the way. Oh, hey, David, I'm a big fan of Lit. I actually even used it in some of my own little projects, side projects, and found it really, really useful. Although it was a rather early version of Lit, like about a year ago. I just wanted to ask. So I heard a lot about the policies and everything, but I wanted to hear like your short version of where do actions come in this whole spectrum of Lit's suite that you have right now. So the Lit actions themselves.
yeah, those the so let's just define those. Basically, great question. So as mentioned, there's the JavaScript VM that runs inside the TEE across this network. What we call a lit action is that logic. It's the JavaScript that runs across the network. It's how you program lit. Policies are just a more specific way to describe these actions. So in the context of the agent wallet, the actions and the policies are the same thing, but we're just like using a different noun there to describe them more specifically. But they're functionally the same thing. And what's really cool about these actions, and this is how they are made immutable but updatable, is you can write a bunch of JavaScript and upload it to IPFS, and Lit can on a CID, a content ID, and Lit can accept that CID. And when you've uploaded data to a CID, the data on that CID is locked to that address, and so that's how you get immutability. You can also point Lit at a contract, and this is kind of built into the policy framework where you can update those policies. And then if you dive into the agent kit, you'll see one of the things that we've been working on is the notion of policy variables. So you can have an action that defines something like a spending limit, which is this JavaScript stored on IPFS, and then have a variable stored on chain. The logic is in JavaScript, let's say for spending limit, but then you can have an individual or a DAO say, oh, I want to update this from $1,000 a day to $10,000 a day for my agent's spending limit, potentially as you get more comfortable with the LLM. And then that variable is just something on chain. Great question. Does
Okay,
that clear it up?
amazing. Hey,
Yeah,
yeah, cleared up, man. Thank you very much.
rock and roll.
Yeah, that was great. Are there any questions from the rest of the team? So I think I see Anita writing. Let's give her a couple of minutes. I was wondering, while she does this, there's been kind of like, I think it was actually a month ago, which is an eternity, but there was a bunch of TEs that were used to share access to a Twitter account. Yes. And people could just tweet from that Twitter account without having the password. That's kind of like if we look at generalizing that topic and have it in a decentralized way, is that something like that can be done on Lit?
Yes, definitely. I'm so glad you brought that up. So like we're very close with those teams. Like the teleport working group inside of Flashbots made He, which was a really amazing project. And the design that is starting to emerge that is quite interesting and exciting, and because the risk there, and I know this happened over at the teleport team, is that if you have a bug in a TEE, because you can't SSH into the TEE, the whole machine can be bricked. And so the risk and the threat is, and the verb that people use here is to say encumber a secret into a TEE. If you encumber a secret into a single physical box, and for some reason the power goes out, there's a bug in the code, whatever it might be, that TEE bricks and you can no longer get access to that secret, it's lost forever. And so the construct that is starting to emerge is using the threshold key almost as the cold storage for these type of secrets. And then as a TEE needs to come online to perform some operation, the threshold network, which is lit protocol in this case, can provision a scoped secret such that a TE can spin up, receive a scope secret, perform some operations for the duration that it needs to, and then that TEE can spin down. And so the difference here, just to kind of like state it on the surface, the difference is encumbering secrets into a single box that has like a specific geographic location and a specific operator versus encumbering secrets into a network, which isn't dependent on any specific box and has been designed in such a way that node operators can join and leave, boxes can go down and come back online, but because the secret is a threshold secret, it's maintained at this kind of like more emergent or higher order level. And so there's very much a relationship that is quite similar to hot and cold wallets, just in the normal OPSEC of being a self-custodial human being, where that same pattern applies to threshold networks as a method to do cold storage of secrets, and then ephemeral TEEs being able to use the hot secrets for like a shorter duration time period.
I'm excited. I don't know if you've heard about Enclave and their EEE, encrypted execution environment using fully homomorphic encryption, which like kind of like eliminates or not eliminates, but just makes it easier to not rely on hardware, which is always like my big deal. I'm an infrastructure guy. Like I deal with hardware every day, and that's why TEs are. I recognize that they're so hard to trust sometimes. So I'm looking forward to see how this combines with projects like EEs, like Enclave and stuff.
Totally.
Okay, we're running out of time.
Maybe can I just make one comment on
Yeah,
that,
yeah,
and then
of
we can wrap up.
Of
One
course.
really fascinating thing about FAT as a technology, as you know, basically, you encrypt some data, you pass it to an FAT service that computes over that encrypted data. The technology continues to improve there, things are getting faster, more performant, et cetera. But then on the output of that transaction, the output is encrypted. Somebody still needs to decrypt that data in order to see what the result is. And so what you'll see is that all FAT teams that are, like at least the ones that have a lot of resources to pursue this, all are also using a threshold key, similar to the construct of lit, to be the key that encrypts the input and then can decrypt the output. Because if you just have a single party managing the key in any FAT scheme, you've kind of like handicapped the nature of that system by having one dependent party holding the key material. So there's totally a really harmonious way for threshold keys and FAT to work together. Just wanted to mention that.
Yeah, absolutely. Thank you. Thank you for jumping in. Just to finish, I'd like you to very quickly sort of like say a little bit the roadmap, but like what should we be really excited about Lit Protocol or in general the centralized secrets, and how or what's the fastest way to jump into it right now?
Yeah, awesome question. So, this is a longer conversation, but if you believe the agent web is coming, which we definitely do, I think it offers like a 10x improvement in how people just interact with the internet, kind of like moving from this thing where you have a million different apps on your phone to something that looks a lot like Her, where the movie Her, where you just ask for anything. Get me a box of donuts, book my vacation to Hawaii, rebalance my portfolio, and then your agent can carry out that operation. What we built with the Lit Agent Wallet, which is a super easy to use toolkit, you just type Lit Agent Wallet into Google, it'll pop up. We see as really kind of like the core piece of infrastructure, again, starting with cryptocurrency transactions, but ultimately being able to manage all user secrets as we move into this wave 2 of AI applications, which is agents doing things on behalf of people. And so the opportunity here to, I think, create a pretty significant impact as a developer is maybe just recognizing that as of today, across humanity, there's two companies that are the main secret managers, which is Apple and Google. I'm sure everybody on this call uses one or the other for managing their passwords, their credit cards, things like that. And the opportunity is like, as a community of professional decentralized builders, that we can ultimately challenge that, and have things that are ultimately more user controlled and less trusting of Apple and Google in the long run. And certainly there's ways to integrate those systems. But I'm definitely excited for a future that is continuing to unfold and be built where the entirety of my life is not trusted to Tim Cook and their company, and instead is trusted to cryptography and incentives.
Awesome. Thank you very much, David, from
Super
Lit
fun.
Protocol. You mentioned the developers.lit.protocol as a place where people can go and start messing with developer singular .litprotocol.com as the place to get started. Thank you for that. We'll include it in the show notes. Thank you for coming. Thank you for responding to our hot and spicy questions. And we hope to follow very closely what's happening with Lit Protocol.
Questions, really cool people. Thank you so much.
Thanks, David. All right.
Later. Bye.
Cool. Thanks, man.